All right, so yesterday we factored polynomials like n squared plus 7n plus 12. And so what did this break down to? Well, if you remember, we took that final number and said, hey, what multiplied together to give us 12? So we said, 1 and 12, maybe 2 times 6 or 3 times 4. Any of those could have produced this final bit of 12. However, only one set of them could produce this middle term of 7. And that was the 3 and 4. So we realized, this broke down to an n plus 3 times an n plus 4. That trinomial factored down into the product of two binomials, which in this case was an n plus 3 times an n plus 4. That's what we did yesterday. Okay. Today, we want to factor polynomials like n cubed plus 2n squared plus 5n plus 10. Now, what do you notice that is different than yesterday's polynomial? Well, you'll notice that it has 4 pieces instead of 3. That's an indicator that we will factor this polynomial using what we call grouping. Excuse me. Okay, so when you see 4 pieces, 4 terms, like here, 1 piece, 2 pieces, 3 pieces, 4 pieces. When I see 4 pieces, or what are called 4 terms, we know we're going to factor it by grouping. So here's what we do. We look at the first 2, we group these 2 together, and we group the next 2 together. Now we say, hey, who factors out of each one? So out of this first group that we have right here, what factors out? Well, they both have an n squared that would come out. That's going to leave behind an n plus 2. Now on the next piece, what do they both have? Well, they have a 5n and a 10. A 5 can factor out, and you're left behind with n plus 2. Now notice that when we factored out this first, basically we have 1 piece here plus another piece here. So we sort of have 2 terms, and in each of those we have the n plus 2. So we actually could now factor that n plus 2 out, and then that would leave behind the n squared plus 5. And that's what we end up with right there. Okay. So, and now you could check it. N times n squared, n cubed. N times the 5, if we're distributing through, 5n. 2 distributed through to each piece now. And notice that is what we had at the beginning, just with these 2 pieces switched. Okay. So that is what we call factoring by grouping. Let's look at another example. So I have this. I say, okay, I see 1, 2, 3, 4 pieces. So I'm going to factor it by grouping. I'm going to group these, and then I'm going to group these. So out of the first group, what can I factor? 2 and 5, nothing. X cubed, x squared. So an x squared can come out. That's the most that can be factored out. I'm left behind with a 2x. X squared times what gives you the minus 5x squared, a minus 5. Plus, now for the second group, a 6x minus 15. Well, a 3 can go into both a 6 and a 15. So I factor out a 3. I'm left behind with a 2x minus 5. Well, looky there. 2x minus 5, 2x minus 5. So I now can pull that out front. And then you're left behind with your x squared plus 3. And if you want, you can go ahead and multiply those 2 binomials. I guarantee you it's going to give you what you have up top. The next one, 4 pieces. Hey, it's got to be grouping. So I group. And I say, okay, let's look at the first group. What can be factored out? I see a 5 and a k squared. I'm left behind with a 2k minus 1, because 5k squared times the 2k is that 10 there, and 5k squared times that negative 1 is that piece there. Now 8k and 4 minus 4. They both have a 4 that can come out. So factor a 4 out. Left behind with 2k minus 1. And again, we have a 2k minus 1. And in this piece of 2k minus 1. So I'm going to go ahead and put it out front. And you're left behind with a 5k squared plus 4. So we factored that 4 pieces into the product of 2 binomials. Excuse me. All right, the next one. Well, let's do the same thing. Now, there's just a little something different here that I want to touch base with. This is one that a mistake occurs on quite often with students. So we start here, 20 and 16. A 4 can factor out, a b cubed, b squared, a b squared comes out. So 4b squared is the largest piece that can come out of those two in the first grouping. 4 times 5 gives me the 20. B squared times a b gives me back my b cubed. Minus 4 times 4 is a 16. So there we are. Plus, now here, 5b minus 4. Nothing factors out. So students forget that technically what really does factor out is a 1. There is a 1 there. And we need to put it so that when we look at this and we say, hey, that piece and that piece both can come out front now because they have that piece in common. You're left behind with a 4b squared, but you do still have plus 1 there. The biggest mistake is kids always write the answers 5b minus 4 times a 4b squared. And I guarantee if you multiply this and that, you're not getting that up there. No, sir, you're not getting that. But this and this are the same. If you multiply 5b minus 4 times that 4 quantity 4b squared plus 1, you will get it. This is a no-no. So you do need to remember that there's a plus 1 that's out here if there's no piece. All right, the next thing we need to take a look at. We group. The problem here, when you have a minus, a subtraction sign right in the middle, if you try to group that, you just change the value because that's minus that entire quantity, 3x plus 6. You cannot do that. You cannot do that. You got to be very careful. This is going to need to be sort of rewritten, squared, okay? And what you want to rewrite it as is sort of a plus, okay? A plus here. And you can just put negative 3x plus 6. Okay? You're going to want to rewrite that and relook at it as plus a negative 3x plus 6, okay? Because if you have a minus sign there and you try to group them, you've now changed it to subtracting the whole thing, and you cannot do that. So whenever there's a subtraction there, we're just going to change this to plus right there, and then just write a negative 3x plus 6. Now we can go about it like we have been. So I have a 2 and a 4, so a 2 can come out. X cubed, x squared comes out. I'm left behind with an x minus 2 here plus. Now, what can factor out? We're always going to factor out a negative piece here, okay? So you have a 3 and a 6, so you're like, oh, a 3. Make sure you're going to factor out a negative 3. That leaves you out with the x. Now, negative 3 times what gives you a positive 6? A negative 2. And notice that that creates the same pieces here, which is what we want. And then I'm left behind with a 2x squared plus negative 3. Now I can just go ahead and rewrite it as subtract 3 instead of plus a negative. Let's look at one more because I know that is confusing. So I see this subtraction sign in the middle. I know I'm simply going to rewrite that as plus a negative. That's all I'm going to do. Just put a plus there, negative. And now you can group them. Okay, so here's what we have. Plus 15x squared. That changed to a plus, and then this was negative 8x minus 12. Okay, so now I'm going to group, and now I factor out. 10 and 15 has a 5x squared, left behind with 2x plus 3, plus, now here, remember, since we had to change that subtraction to a plus negative, we're going to want to factor out a negative piece here. 8 and 12, a 4 is the largest, so we'll factor out a negative 4. We'll be left behind with a 2x. Negative 4 times a positive 3 gives me the negative 12. And notice that we have created a common piece of 2x plus 3. Common factor in each of the two terms there. And this gives me 5x squared. Instead of plus negative 4, we can just say subtract 4. That should give you enough in order to do group factoring by grouping.